The Large Hadron Collider is one of the most fascinating scientific experiments of our time, having produced groundbreaking results since its inception. The detection of the Higgs boson particle by the LHC 10 years ago was an interesting discovery, and scientists have continued to push the boundaries of our understanding of particle physics ever since. So what's the latest discovery made by scientists at the LHC? And why has it piqued the interest of entrepreneurs like Elon Musk? Let's jump into the video to find out. CERN, or the European Organization for Nuclear Research. It's a world-renowned particle physics research organization. CERN was founded in 1954 and is headquartered near Geneva on the border between Switzerland and France. The organization owns several particle accelerators, including the world's largest particle accelerator, the Large Hadron Collider (LHC). The LHC is 27 kilometers in circumference and 175 meters below the Swiss-French border. The collider fires particle beams at nearly the speed of light, causing them to collide and generate debris from the high-energy collisions. This method enables physicists and researchers to investigate subatomic particles, such as electrons, protons, photons, and quarks. Since its inception, the LHC has assisted scientists in solving a number of cosmic mysteries. The discovery of the Higgs boson particle in 2012 was a turning point in physics. The Higgs boson particle, also known as the God particle, was predicted by the Standard Model, and it's responsible for giving particles mass. The LHC's work, however, did not stop there. Scientists are still working to solve the universe's mysteries. The LHC recently made an unusual and quite frightening discovery that no one had ever seen before. The discovery is so mystical that several scientists believe it to be ghost-like. But what exactly did the LHC recently discover, and what is the reason for keeping it hidden for so long? Physicists from across the world were incredibly thrilled to see the world's most advanced high-energy particle collider become operational after being shut down for 3 years. Engineers decided that the Large Hadron Collider needed to go through a series of adjustments and amendments before its next set of discoveries. It then returned with full force and a new maximum beam of energy and gave strange results. The results were so puzzling that several theories have been proposed to explain it. The collider consists of 4 crossing points where the accelerated particles collide, and each one of its 7 detectors that surround the crossing points is designed to identify several phenomena. Some researchers believe that LHC might have discovered a new type of particle, but no one agrees on its properties, and there are contradicting theories by different scientists about the nature of this mysterious discovery. The discovery has left scientists and engineers scratching their heads trying to figure this one out. So far, they have several theories that might explain the nature of this discovery. According to one theory, the discovery is related to the Higgs boson particle. Scientists are currently searching for a larger source of these new particles, as predicted by supersymmetric theories. The Standard Model can explain almost all particle physics discoveries, but it cannot explain the nature of several other phenomena, such as dark matter and dark energy. Tesla CEO Elon Musk has been interested in these two topics for quite some time. It's probably because of this that SpaceX may discern the center of attention this time. The term hadron refers to subatomic composite particles made up of quarks held together by an extremely strong force. It's similar to how electromagnetic force holds atoms and molecules together. Protons, baryons, and neutrons are the most common hadrons. Mesons, such as the pion and kaon, are another example. The discovery at the LHC suggests the existence of a new type of hadron, one that does not fit into the existing classification system. Another theory suggests that the discovery is related to the strong force, which is responsible for holding protons and neutrons together inside an atom's nucleus. The strong force is mediated by particles known as gluons, and the discovery could mean a new type of quark-gluon bound state. Finally, some scientists have proposed that the discovery could be related to the nature of dark matter, which is a type of matter that does not interact with light and has only been inferred from its gravitational effects on visible matter. Dark matter accounts for approximately 85% of all matter in the universe, but its nature is unknown. Neutrinos are ghostly particles. These mysterious particles outnumber protons by 1,000,000,000 to 1, and they are the most abundant particles in the universe. Despite their abundance, they are extremely difficult to analyze due to their neutral nature, making detection difficult for scientists. Neutrinos are one-of-a-kind particles in that, unlike other particles, they can be neutral to thousands of compounds on the planet, making them difficult to detect. This means they can pass undetected through the body. It's also one of the reasons scientists have had difficulty capturing enough of them. Supernovas and radioactive decays are the two main sources that produce neutrinos. The sun produces a large amount of neutrinos, many of which collide with Earth. Scientists have set up various detectors over the years to detect and trap these ghost particles. However, their experiments have only detected 1/3 of the amount that they require. As they travel through space, these special particles carry a vast amount of information with them. Neutrinos, unlike any other particle, cannot be deformed by interactions with other matter. CERN's neutrino discovery was the first time neutrinos were discovered within the LHC or any other particle accelerator. This significant breakthrough provided new opportunities and hope for other scientists to investigate the subatomic world. However, determining which form the neutrino is in has proven difficult. One of the reasons scientists haven't detected enough neutrinos is that they bounce between different forms as they pass through the sun and the Earth. These forms are ordinary neutrinos, muon neutrinos, and tau neutrinos. Scientists have been ignoring these forms, making their research extremely difficult. In response to these challenges, scientists from the Phaser collaboration created the Phaser Nu detector, which is made of solid metal plates of lead and tungsten, as well as various layers of light-detecting emulsion fixed in the middle. Neutrinos collide with atomic nuclei in dense metal plates, resulting in particle debris. The emulsion then reacts with the neutrino remnants, imprinting the tracing contours of the particle as it passes through it. Scientists create the emulsion and examine the neutrino trails that pass through it. This helps in detecting the various forms of neutrinos. Scientists are currently working on a larger version of the Phaser Nu detector that can distinguish between neutrinos and their antimatter antineutrinos. Several scientists have stated that they believe dark matter can explain the extra gravity that binds galaxies and their clusters together. Dark matter is an unseen component that only interacts with ordinary matter via gravity. Neutrinos are now being suspected to be dark matter, but only if their rest mass is greater than 0. Neutrinos barely interact through weak force and gravity, and this is very similar to how dark matter cannot be detected, at least through interactions with light. As a result, neutrinos are currently the most popular dark matter theory. But whether or not neutrinos or dark matter are 100% confirmed remains to be seen. Neutrinos are very important in astrophysics. They are produced in large quantities during supernova and other cosmic events, and their detection can provide information about the processes that take place during these events. A supernova, for example, occurred in 1987 in the Large Hadron Cloud, a satellite galaxy of the Milky Way. The supernova's neutrinos were detected by several neutrino observatories on Earth. Neutrinos are also used to investigate the universe's structure. Scientists can determine the density of matter in the universe by observing the cosmic microwave background radiation. This method, however, only provides information about visible matter in the universe, which is estimated to account for only about 5% of total matter in the universe. Scientists can learn about the distribution of the other 95% of matter, including dark matter, by studying the distribution of neutrinos. We hope you enjoyed this video. Make sure to subscribe, like the video, and watch these ones as well.